All right, in this video, we're going to continue our discussion of whether something's a function and domain and range, but we're going to look at slightly more complicated graphs, equations that produced slightly more complicated graphs than the basic ones. All right, so this handout was completed by first thinking about what kind of graph to expect, which basic graph is it like, and then going ahead and getting some data and actually plotting it. So let's go ahead first off, and just on these first 6 that we're looking at, can you just look at them real quick and determine which are functions? Okay, try it before I go through it. Think about it before I show you the answers. Okay, think about which of those are functions before I actually go through it. Okay. All right, so looking at that, there are 2 that are not functions. Okay, these are functions, but these 2 are not functions. All right, I'm going to scroll down to a couple additional ones I have here. Both of these are also functions. Do you see how they would pass the vertical line test? So both of those are functions as well. Okay. All right, now let's go back. And let's think about domain and range. And what I want you to do first is just look at which of these, let's focus on the domain, which of these would have a domain that would be all reals. And remember, when you're thinking domain, you should be thinking from left to right. When you're thinking about range, you should be thinking about what are the values of the y coordinates. Okay, so up and down. All right, let me do the domain in red, and I'll do the range in green later. So the domain on this one would be all reals, because every point, if I were to project them, smash this graph so that every point is projected to the x-axis, those arrows mean that this keeps going. So I could get a point from way out here or from way over there. So the domain is going to be from negative to positive infinity. Okay. All right, let's do the domain of these 6. Okay, so here when I do domain, be thinking about from left to right. Just go ahead and write out the word since I have the space. And then like this point would cover up there, this point would project there, all of these below here would cover up the x-axis there. And then these points and those points would cover up all the rest of it. So the domain would be from negative to positive infinity. So what it is how that keeps going out as it goes up. You could have an x value. You can plug in any x you want, can't you? When you look at the equation, you can kind of confirm that. Okay. Now this one, the domain is a little more interesting. See how there are no points over here? There's no way to get a negative x. No matter what you plug in for y, you're going to be squaring it. See, that's x equals y squared. No matter what you plug in, you're going to square it. So that's always going to be a positive number. That is why you only had, if you project these points to the x-axis, this is why you're only covering up from 0 over, including the 0. Okay. All right, let's look at this one. Domain here is interesting because of this gap right here, just like that gap we had on the basic graph, y equal 1 over x. But this gap is over some. You see, here's what's causing it. When you plug in a 2 right there gives you a 0 in the denominator, which is what causes you to have this gap right here. So for this one, you're going to have everything on the x-axis covered up until you get to 2, and then you can go to the other side of 2. You just can't be at 2 itself. So it's going to be from negative infinity to 2, and then from 2 to infinity with a union symbol in between. So what we're saying is all reals except 2. All right, now there's a faint line on here in a couple spots. It's not an x-axis. It's this line and this line. That just has to do with the printer I used. Put that line on there. Okay. So it has no meaning. All right. The domain of the next one, if I projected every point to the x-axis, okay, it would cover them all up. So the domain would be negative to positive infinity. Anything you want, you can plug in for x. There's no limitation. Here there was. So if we connect it back to what we started talking about regarding domains from equations, this one has a trouble spot. This one has a denominator. But there's no issue with that. You can plug in any number you want for the x and it's going to work. All right, now here, it doesn't look like there's a trouble spot, but if I rearrange this y squared, got it to where y was on a side by itself, I could subtract the x squared and then square root both sides. I'd actually have a plus or minus out in front of that, but you see the radical? So it really has like a camouflaged trouble spot. Okay, it's what causes the domain issue. The y being squared is what made this not be a function. This is how I could tell it was not a function. And then the fact that you got the radical is what causes you to have some domain restrictions, because you can't put stuff in there that's going to give you a negative number. So like 4. 4, if you put that in there, would give you the square root of -7, which is not real. And that's why there's no points over here. This is 3, 0, and this over here is -3, 0. Okay, so the domain, if you smash these points to the x-axis, you would just be covering up everything from -3 to 3, including those. Okay. All right, let's continue with our domain discussion on 2 more. All right, with this one, the domain would be all reals. Okay, there's no trouble spot. You know, if I projected things to the x-axis, it would cover the whole x-axis. If I smashed all the points down to the x-axis, excuse me, the entire x-axis would be covered up. All right, but then this one has the radical, which we know is an issue, and we even saw that if you plugged a -2 in, it didn't work. This point right here was -1, 0, and that's where that graph starts. Okay, so your domain on this is going to be just from -1 to infinity. See, if you projected to the x-axis, it's just going to cover up from -1 to infinity. Okay? All right, so that's looking at domain. Domain, by the way, is the most important thing. I think it's reasonable to expect you to do range, especially if the graph is given to you, but range from an equation can be a bit of a challenge. So let me get ready to do the range on these two, and then we'll move up and do the range on the others. Okay, let me do the range in green. Okay, so range, we got to switch our thinking. So for range, we should be thinking about the y's. So you should be thinking about y coordinate of a point, which would be projecting the point to the y-axis to see what the y coordinate is. And you see how we would cover up everything up here, but we would have no points below the x-axis? The range would be from 0 to infinity, not including 0. Okay. All right, and the range on this one, we don't have any points down here either, so it looks like it's from 0 to infinity as well, because this keeps going up. So I would have ordered pairs with y coordinates on up like that. This point would be here and so on. The difference is that we actually do get a 0, so we have to put a bracket on that. Okay, so 0 included, and then on up would be the range. Okay, let me back up now, do the range on these others. All right, I'm going to get rid of some of the red and all. Let's see if I can get it off of there. Okay. We'll clean up these top 3. We'll do the range on these top 3 first. Okay, so I'm going to do the range in green. Talking range now. All right, so for the range, you can see the arrow keeps going down, the arrow keeps going up. The range would be negative to positive infinity. All right, on this one, let me move that, what I just wrote, out of the way a little bit because I want you to see this. See how on this one, if you projected things to the y-axis to figure out the y-coordinate, how it would be just all the numbers from whatever that is on up? So this plays an important role. That point right there was the 0, -4. So the lowest, the bottommost point is 0, -4. So the range would be from -4 on up. Okay. All right, but now this one's a parabola, but it's a parabola turned on its side, and it keeps going down here, keeps going up here. So you'd actually have a range of all reals on that one. Okay, so think about those for a minute. Let me kind of erase this so we can see the graph a little better. All right, so we're going to finish up by doing the range on these three. I'll do the range in green. Okay, let's see, let's do the circle first. This circle was centered at the origin. Okay, and so like this point right here is the highest point, and it's the point 0,3. This point's the lowest point, it's the point 0, -3. And if you projected all the points to the y-axis, it would cover up everything from -3 to 3. Okay. All right, let's move to the absolute value one. Okay. This is the lowest point, and it's the point -5, 0. And then see how it keeps going up? So if we projected all these over to the y-axis, we would cover up everything from there on up. So the range would be from 0. Make sure you're thinking about the y-coordinate because we're doing range now, right? So it'd be from 0 on up, 0 to infinity. Okay. All right, and then the range of this one is similar to the domain, but it's a little trickier than it was on the basic graph. Let me see if I can write it just down here. So it's going to have a similar look because the y's go on up here. So the if you projected everything over to the y-axis, that point would have a y-coordinate there, that point, and it keeps going up. So you'd have y-coordinates as high as you want them to be. And it would go all the way to the x-axis. Remember that little faint line you see is not the axis. The axis is here. This is the x-axis. All right, now there is a gap right there. So then we jump over that x value, and then all these points would have y-coordinates on down there. So it's from negative, and you always make your interval be from the smallest to the largest. So from -infinity to 0, and then from 0 to infinity. Okay. All right, so that's the range on all of them. So range, I'm focusing on my y's when I do it. So I'm trying to, if you like the idea of smashing, you can smash your points. Imagine all those points just getting smashed to the y-axis. Okay, and then let you look at these again. All right, let me erase what I did here so you can see what that was. Okay. So you kind of see why this is from 0 on up, not including 0. This one is from 0 on up, but it includes the 0. All right, and then one last thing I want to comment on is I organized these examples in columns. So see those 4 right there? They're all functions, right? They're all functions. They have various domains, but they're all functions. Okay. So are the 2 that I have here in the middle. They're functions, but they have kind of a different flavor than the other ones did. Because it's like, they see how on this, you have points that line up horizontally. Okay. So we have points that line up this way. Let me get a pen. Line up that way. you didn't have that over here. Do you see how all the graphs in the first column, okay, if you drew a horizontal line, let me get some other color like a yellow. If I drew a horizontal line on the graph, it would only hit them in one spot. Okay. And that doesn't have anything to do with whether it's a function. Okay. To be a function, you need a vertical line to hit the graph in one spot. And that's true for all the ones in the first column, and all the ones in the second column also are functions. A vertical line would cross the graph in only one spot. Okay. Let me get rid of some of the range stuff. All right, so what I'm getting at on this last piece is that, yes, everything in the first two columns are functions. Okay, everything on the whole entire page are relations. So this is a special kind of function. So this is a function, but it's a one-to-one function. I think I need a darker color. Let me get my purple. Okay, so this is we call it a one-to-one function. So it has an additional property. So it fits the property of a function, okay, because it passes the vertical line test. But then these have an additional property that they also pass the horizontal line test. So for each x, there's only one y. That makes it a function. But the ones in the first column are one-to-one functions. For each y, there's only one x, okay? So these here are functions, but they're not one-to-one, okay? And then these here simply are not functions. So that's what's going on in that last column. So to me, I see my relations kind of broken up into those three categories. These are both functions. It's just the first column has a special property making it one-to-one. So I wanted to tell you about that because sometimes people don't want to include the ones in the second column, don't want to think of those as though they're functions. All right, and then one other misconception and a lot of students hang on to for a while is that domain determines whether it's a function. Those are completely separate ideas. So notice that our functions can have a domain that's all real numbers, like we had here, here, and here, but your domain might have a missing value, okay? Or it might only be from like -1 to infinity. You know, your domain doesn't have to be all reals in order to be a function. All right, so that kind of finishes up what I wanted to say about this, just a little more practice with identifying whether something's a function, but then also trying to figure out what the domain and range is looking at graphs, if you have graphs.